All right, next up, we're going to take a look at hydration reaction. So you think hydration, you're drinking water to get hydrated. And so what we're going to do is add water across our double bond. And so one carbon is going to get an H, the other one is going to get an OH, and combined they are water, right? So we're hydrating our molecule. And so we're going to learn a multitude of ways to do this. Each have their pros and their cons. We're going to start off with acid catalyzed. Hydration. So in this case, we have our alkene, and what we do is just add some acidic water, and then that will add across the double bond, right? We add an H and then an OH, so it's added across the double bond, and notice that we here get the Markovnikov addition, right? The alcohol goes on the more substituted, the hydrogen goes on the less substituted. And so this mechanism does indeed go through an carbocation intermediate. And so the first step of this is our proton transfer. Our pi bond here is going to attack an H plus. You can draw this connected to an H3O plus or just H plus floating around by itself. Either one is fine, right? The first step is going to be a proton transfer. And then if we think about the proton transfer, it's going to leave a positive charge somewhere, right? It could leave a positive charge on the carbon on the left or the carbon on the right. The carbon on the right is the tertiary carbon, and so it will be the one that forms this carbocation, and so the hydrogen will add to the left side. After this, we have a molecule of water nucleophilically attack our carbocation. To give us almost our final product, right? But in this case, our alcohol is still protonated over here. And so the last step that occurs is another molecule of water comes over here and deprotonates this, right? This occurs another proton transfer to give us our final product. And you can see that is indeed a Markovnikov addition. And so you can think about different things that we learned about alkenes. Think about the more substituted alkene. In this case, will be more reactive. Why? Think about the more stable carbocation. So you can see how everything is really building upon itself in this course. And then if we think a little bit about some more stuff we did a second, we'll get something weird. So we'll say, but wait, didn't we learn this reaction right here? To form our alkene, we didn't use H3O plus, we used concentrated H2SO4, but that's the same thing as H3O plus, right? So we told you that was going to form an alkene. Now I'm telling you that the exact opposite is occurring. And so what's going on? Well, it all depends on the conditions. Really, this arrow should be an equilibrium arrow, and so we can push the equilibrium one way or another. So for example, if we've got an alcohol, and if we want to dehydrate it, right, get rid of this OH, make a double bond, we're going to use some concentrated sulfuric acid, right? You think about our products, we get our alkene plus some water. And then if we want to do the opposite of this, we just use some dilute acid, right? So maybe some dilute H2SO4, which if you think about it is just going to be mostly water. And that'll push our reaction to the left, right? This is just an application of Le Chatelier's principle, right? So we're increasing the amount of product, in this case, our water, and so we'll shift it to the other side. And we'll see a lot of this, right? A lot of these reactions are going to be reversible. It just depends on which conditions you put them under. And so just some other things to keep in mind. What about the stereochemistry here? Again, we're going through a carbocation intermediate. And so we'll get a racemic product. And then, of course, you have a carbocation intermediate. What do you need to keep an eye out for? And that's rearrangement. Right? This can always occur with these carbocation intermediates, which is actually one of the main downsides of these acid catalyzed reactions. That and the fact that you're using a strong acid, so it might not be sensitive to other functional groups in your molecule. So we'll learn some better ways to do this.